Good morning, guys. Today we're going to talk about proportional versus non-proportional linear relationships. So we're going to look at some tables, equations, and see what is considered proportional and what is considered non-proportional. So first thing, let's look at this. Proportional relationships. If the equation passes through 0, 0 and is in the form y equals kx, then the relationship is proportional. So if we look at this example, y equals 3x, that would be a proportional relationship as far as equations go because you're not adding or subtracting anything, which tells us that we go through the origin. What we're really going to do is take this table and make it bigger and go through. So the real way we can tell if a table is proportional or not is we take our ratios or each of our coordinates except for 0, 0, so -6, -2, -3, -1, 3, 1, and 6, 2, we put y over x. So we're going to put y over x, -6, -2, -3 divided by -1, 3 over 1, and 6 over 2. And if they give us the same number every single time, then it is proportional. So if we look, -6 divided by -2 is 3. -3 divided by -1 is 3, 3 divided by 1 is 3, and 6 divided by 2 is also 3. So let's throw this on a graph. It goes through the origin, and it is a straight line, which means it is proportional. So let's look at a non-proportional example. So if the ratio of x values is different than the ratio of y values for select ordered pairs on the line, then the equation is non-proportional. Also, if it's in the form y equals mx plus b, so meaning we are adding or subtracting something, that would not be proportional. So let's take this table and make it bigger and look through it. So again, you can already see that we don't go through the origin, so we don't have the coordinate 0, 0, which would automatically make this not proportional. But we're still going to take all of our coordinate pairs and we're going to simplify them by putting y over x, so -5 over -2, -3 over -1, 1 over 1, and 3 over 2. So we end up with 2.5, 3, 1, and 1.5. Since none of those are the same, then this is not a proportional relationship. And we see that it doesn't go through, so then that's not proportional. So let's look at two graphs. Which one of these would be proportional? We need to go through the origin and be a straight line. So the only one that goes through the origin is the first one. That second graph is higher. It's got a y-intercept at +3, so that would not be proportional. So next, tables. So again, if we look already, we can see the first one does not go through 0, 0, so automatically that makes it not proportional. However, what if we're not given our 0 or our y-intercept? We want to make sure. So we're going to go through each one. So 0, 10/3, 5/2, those are not the same, but on this other table, I get 5 every single time. So that would make the second table proportional. The first table is not proportional. And that is it for that. So good luck, guys. I wish you well.